Students, welcome to my video classes. Today and in subsequent classes, I am going to discuss one of the very important topics from the chemistry. It will be discussed in the physics also. This topic, that is symmetry elements, symmetry operations and group theory. These topics considered as one of the toughest topics in the chemistry. Many students have very difficult to understand these topics. Therefore, I have simplified as much as possible and I have approached through the student's perspective to deliver these topics. I request you to watch all the videos one by one and clear your doubts. If you have any doubts, please comment in the comment box. I will discuss the answer and clear your doubts. Okay, let us go to the topics. Let me check the video. Okay, the first is what is symmetry elements and what is symmetry operations. Why the term symmetry? You know, we are experiencing with a lot of symmetrical objects, buildings, greeneries, etc. etc. We say Taj Mahal is so beautiful because it is so symmetric. A rose flower is so symmetric. Naturally, in nature, all symmetric are beautiful. Like our physical objects, our architects, or flowers, molecules are also symmetric. There are symmetrical molecules, highly symmetrical molecules, less symmetrical molecules. Therefore, there are attempts from the scientist to classify the molecules based on their symmetry. Therefore, symmetry is the property of the molecules like any other objects, and this property has been used to classify the molecules. Okay, and this classification has been done in group theory. Scientists have grouped the molecules based on their symmetry. Therefore, first of all, our object is to find out what are the symmetries present in the molecules. What are the different types of symmetries present in the molecules? To do that, we should know different possible symmetries in the molecules. That's our first aim. First of all, I am going to explain what is symmetry elements and what are symmetry operations. Symmetry elements are axis or plane or point in the molecule with respect to symmetry operations are doing. Symmetry operations are doing. Symmetry operations are doing. Therefore, these are the axis or plane or point in the molecule with respect to that axis or plane or point. Symmetry operations are doing. Simply, symmetry elements are the tool for symmetry operation. Symmetry elements are the tool for symmetry operation. Tools of symmetry operations. Okay, they are nothing but tools of the symmetry operations. Fine. Now, what is a symmetry operation? Operation, the word itself, symmetry operation, it is the operation or action doing with respect to symmetry elements, comma, after the operation, identical or indistinguishable and superimposable orientations obtained. Okay, it is action. Symmetry operation is the action with respect to doing with respect to symmetry elements. Full stop. After the action or operation, identical, this is very important, identical or indistinguishable and superimposable orientations obtained. Okay. Therefore, this is the action, this is a tool. Okay. What are the tools? Maybe axis, maybe plane, maybe point. Okay. Fine. Yes. Now, what are the different symmetry elements and symmetry operations? Okay. What are the tools? What are the actions? Symmetry elements and symmetry operation. Symmetry element first is axis, that is represented by Cn. This is representation. Operation is called rotation. That is, you are rotating. This is axis. This is a sphere. Suppose you are rotating like this. Okay. Fine. Now second, plane. That is sigma. That is called a reflection. Okay. Suppose you have a plane like this, a plane, and this is an object. You keep the plane at the middle of the notebook. Reflection. Suppose it is a mirror plane. Therefore, this part, you keep the plane here. Upper part, lower part. Lower part is the mirror of upper part. Upper part is a mirror of lower part. Like that. Reflection. Okay. Third point, center point, that is I, inversion. Now, improper axis S, it is nothing but a rotation followed by reflection. Rotation followed by reflection. Okay. Then next is identity. E, doing nothing or rotate 360 degree. What is rotate 360 degree? Like that. Or doing nothing. Suppose I am the object. My friend is your side. Now, doing nothing. This is doing nothing, identity. Or second is rotating 360 degree. Okay? Both are same. Doing nothing and rotate 360 degree. This is called identity. Okay? Now, for convenience, I will say that axis of symmetry. This is called a plane of symmetry. This is called the center of symmetry. Point, center of symmetry. This is improper axis of symmetry. This is identity. Now we will use these words: axis of symmetry, plane of symmetry, center of symmetry, improper axis of symmetry, then identity. Identity, capital identity. Okay? And their symmetry operations. Now first our idea is going to axis of symmetry. Now we will go to first axis of symmetry. Yes? Okay, dear students, axis of symmetry. We can go to first axis of symmetry. Axis of symmetry represented by Cn. Okay? What is axis of symmetry? And the symmetry operation is called rotation. Rotation. Axis of symmetry, it is an axis passing through the center of the molecule, comma, the molecule is symmetric with respect to that axis. With respect to that axis. What is rotation? What is rotation? Rotation is the symmetry operation carried out with respect to axis of symmetry. Rotation is a symmetry operation. Okay. Now, first of all, how do I identify whether the molecule has axis of symmetry? Whether the molecule has identification of presence of axis of symmetry. Okay, identification of presence of axis of symmetry in a molecule. That's very important. How do you identify that? Normally, okay, we have three axes. One is x-axis, this is z-axis, okay, and this is y-axis. That is horizontal to this body is x-axis, vertical to the body is y-axis, perpendicular to the body is, vertical to body is z-axis, perpendicular to body is y-axis. Now you want to check whether the molecule has any axis of symmetry. First you check whether it is x-axis or y-axis or z-axis. I will take you one example, H2O. H2O, this is the structure of H2O. I consider x-axis first. X-axis will be like this. Does this molecule axis of symmetry along x-axis? No. Why? Because this side has hydrogen, this side has no hydrogen. Therefore, this molecule has no x-axis. Now, I take a same molecule. Okay. I consider y-axis like this. Does this molecule y-axis of symmetry? Yes, because y-axis one edge like that here also. Now I also consider this is y-axis. Okay, y-axis will be like this. Okay, it has y-axis. Now let us consider hydrogen. Now I consider like this. This is z-axis. Does this molecule z-axis? Yes, because this side and this side equal. Okay, therefore this molecule has, water has an axis of symmetry along y direction or z direction, but not in x direction. Therefore it is very careful, you have to check whether the molecule has axis of symmetry. Now I will take another example. Suppose you have a molecule like this, HOCl. Does this molecule x-axis? No. Does this molecule y-axis like this? No. Because this side is H, this side is Cl, this side is H. No y-axis. No x-axis, no y-axis. Again the molecule Cl, H. Does the molecule z-axis? No. Therefore, H2O has an axis of symmetry, but HOCl has no axis of symmetry. Therefore, what is axis of symmetry? It is an axis passing through center of the molecule, and the molecule is symmetric with respect to that axis. That's all. Okay. Now, the axis of symmetry is represented by Cn. What is N? N is called N is equal to 360 divided by theta. Theta is called the angle of rotation which gives indistinguishable structure, indistinguishable geometry. Very, very important. We said that water has an axis of symmetry. Very simple to identify that axis of symmetry or axis of symmetry. But what is the angle? What is the angle of rotation which gives indistinguishable? Okay, what is that angle? We can discuss that. Very important. I put it is hydrogen 1, hydrogen 2. Okay. You rotate the water in 90 degrees. Suppose water is like this. Once again, students, water is like this. Suppose this is also black. This, imagine water is like this hydrogen, and axis like this. It is like this in the plane of the board. Okay, in the plane of the board. Now, you rotate it is 90 degree. How should be the 90 degree? If I rotate, this is a molecule now. If I rotate, it will be 90 degree means it will be like this. Am I correct? Yes. This is towards you, this is away from you. How do you represent that? Oxygen here. That is towards you, away from you. Okay? Away. It will be like this. Earlier water was like this, now this. Is it distinguishable or indistinguishable? This is not indistinguishable because your water was like this, now it is like this after 90 degree. Therefore, 90 degree rotation does not give you indistinguishable geometry. Indistinguishable means it should be like this. Okay. But I again rotate it. Again rotate is 90 degree. Or I rotate it to 180 degree. What I will get? Dear students, you should not be very careful about the rotation. It was like this after 90 degree. Again I rotate. I got like this. Am I correct? Okay. Suppose it is H2, this is H1. Now I rotate. This is towards you and this was away from you. H2 become here. That is your O big H2 from here. This H from here. Now look at this structure. Earlier the position hydrogen H2. There is another hydrogen. Hydrogen is same. This just for identification. You have an hydrogen at that same position. In this position of hydrogen, you have an hydrogen, same position. Okay? This A, B, C. This A and C are called the indistinguishable superimposable configuration. What is the word indistinguishable and superimposable? That very careful, my dear students. It should be very much clear. What is the meaning of indistinguishable and superimposable? A and C. In the position of hydrogen, you have hydrogen. In the position of hydrogen, you have hydrogen here. But here, this A and B is not indistinguishable. This is distinguishable because how is distinguishable? This is in the plane of molecule, it is out of the plane of molecule. Distinguishable. Therefore, A and C are indistinguishable. Therefore, water will give you a symmetry element C2 because here theta is equal to 180 degree. Theta is equal to 360 is equal by 180 degree, that is 2. Therefore, water has a C2 axis. Very careful. Water has a C2 axis. What is this meaning? An axis passing through the center of the water. When you rotate by 180 degree, why 180 degree? Because theta is equal to 180 degree, you will get a indistinguishable geometry. Water has no C for, suppose theta is equal to 90 degree. Theta is equal to 90 degree, n is equal to 360 by 90, that is 4. Water has no C4 axis. Water has only C2 axis. Do you agree? Water has C2 axis because when you rotate into 180 degree, it gives indistinguishable geometry. Okay. Now, there is another word I have said, identical. Do you remember that statement? Indistinguishable, superimposable or identical. Now I keep on rotating this again. This is now, it was like this, am I correct? After 180 degree, I got like this. Okay. Now I rotate again 180 degree, that is 360 degree, I got like this. That is same. It was like this. When 180 degree, it become like this, red in this part. Again 180, that is 360 degree, I got like this. Okay, correct. That geometry, that is, if I rotate into 360 degree, I got H2 here again, H1 here again. This is called, suppose it is called E, D. A and D are called identical. And C are called indistinguishable and superimposable. A and B are distinguishable. Therefore, a molecule will be said to have a rotational symmetry when it rotates with a respective axis with a particular angle to give indistinguishable and superimposable or identical. Fine? Yes. Okay. Now we can go to some more examples having symmetry elements. This is a water. I keep on checking the videos. Now suppose this second molecule BF3, it's a planar molecule, trigonal planar molecule. The molecule like this. It has an axis like this. Okay, let us discuss what are the different axes it possesses. First we can take an x-axis. Suppose it has not this axis. But if you have an axis like this, look at here, this axis, y-axis, y direction, yes, it is symmetric all. Now, what is the rotation for this? This is 120 degree, F1, 2, 3. I rotated 120 degree. What I will get? I rotate like this, B, F, when I rotate, F2 become here, F3 become here, F1 become here. Same. 120 degree. It keep on. Therefore, it has a C3 axis. Because 360 by 120 is 3. Now, another option I have. Suppose I have an axis like this. Z axis. It is symmetric. Really symmetric. Look at here. Because here and F, here and F. I rotate C2 axis. This is C2 because you are rotating like this. Now, what I am getting, this F1 is here, but here F3, here F2. How many C2 is possible? I have a C2 like this also. I have a C2, this is also C2, this is also C2 because I can rotate like this. Okay? I rotate F2 here, F1 here. Therefore it has 3 C2. Do you remember? Just 3 C2, 1 C3. Now, have you noticed that C2 means 180 degree? 180 degree. 180 degree. When you rotate 180 degree, how do you write the products? 180 degree, how do you write the products? This should be transfer. 180 should be transfer like this. Upper should down, down should upper. Left should right, right should. Suppose you rotate like this, 180 degree. 180 degree rotation products, how do you write? How do you write 190 degree rotation products? Left should be right, right should be left. That is the simple method for writing 180 degree rotation products. Okay, how do you write? Left should be right, right should be left. Okay, therefore this has C2 axis and C3 axis. C3 axis and C2 axis, this molecule has. But we can go to another example. Another example. NH3. NH3. NH3 has pyramidal shape. H, H, H. We can take it like this. Pyramidal shape. Pyramidal shape. Fine? Yes. Now, let me give you any mix. Yes. It has no axis like this. It cannot have an axis like this, but it can have an axis like this. Yes. Look at this. Suppose this is the axis. It can have an axis like this. Am I correct? Now I just rotate C3 axis. This is towards you. Now I rotate. All are equal. Hydrogen, hydrogen, hydrogen. I rotate. Okay. Now this. Because this is also hydrogen. No problem. Now again I rotate. Okay. This towards you. Therefore it has a C3 axis through the center. C3 axis. But it has no C2 axis. No C2 axis. No C2 axis. Okay? It has no C2 axis. No C2 axis. C2 axis means, suppose I rotate. All up, all down become up. When down become up, there is nothing. Therefore, it has no C2 axis. It has only C3 axis. Okay? Now we will go to, therefore, from these examples, certain molecule, water, this is our criteria. Water has C2 only, ammonia has C3 only, but BF3 has C3 and C2. Therefore, molecule can have more than one axis. Therefore, axes are divided into 3 types. That is principal axis and subsidiary axis. Subsidiary axis. If a molecule containing more than one axis, they are classified as principal axis and subsidiary axis. Principal means axis which has highest n value. Highest n value. All other axes except principal axis, Cn, except principal axis. Therefore, in this case, this is the principal axis. This is the principal axis, principal. This is a subsidiary. Here only one axis, that is a principal and subsidiary. Okay? Therefore, a molecule have more than one types of axis, which is called the principal and subsidiary axis. The next is, next classification, very important. Next classification is Again the classification based on Cn and C2 axis. This is principal, these are subsidiary. Okay, next classification Cn and C2. That is molecules having Cn and n number of C2. Very important. This NC2 is perpendicular to Cn. Molecules having a principal axis Cn, whatever the number here, suppose if it is n is equal to 3, 3C2, n is equal to 4, 4C2, like that. N is equal to 2, 2C2. And not only that, C2 is perpendicular to Cn. Suppose this is Cn, C2 will be like this. C2 will be like this. Okay? That is C2 is perpendicular to Cn. And the molecule having Cn but no C2. No C2. It has only Cn. Here what are the examples? Already we said H2O, NH3, PCl3. That goes on. Okay? Yes. H2O, NH3, PCl3, ClF3, IF3. It goes on like that. Okay. H2S, H2 selenium. Like this example. That is bend shape, pyramidal shape. Bend shape, pyramidal shape, normally like that. Here you have square planar shapes, trigonal planar shape, octahedral shapes. Yes, they have Cn and NC2. That is molecule having square planar, trigonal planar, octahedral. They have C2 and NC2. We can check some examples. First, I'll go to. I have already given you one example. BF3. First example. BF3. F. Okay. What is the principal axis? Principal axis is C3 crossing the B. Okay. Now it has 3 C2. That is what this is a 1 C2, 1. This is another C2. This is the another C2. 3 C2. All these C2s, because the 1 C2 is like this. This is suppose C3. 1 C2 like this. Okay, 1 C2 like this. This is your C3 axis. 1 C2 like this. Another C2 like this. 1 C2 like this, another C2 like this. Okay. Therefore, it is perpendicular. This is perpendicular, and this is also perpendicular. 90 degree. Because this is your C3 and this is your C2. C2 like this. Therefore, the angle is 90 degree. Another example, second example, platinum, Cl. This is square planar geometry. What is this? Square planar geometry. 2 minus. You have a principal axis is C4 crossing the platinum. C4. Okay? C4. Principal axis. C4. Now you have this y-axis is the principal axis. Am I correct? I said it this way. X-axis. Look at this x-axis. It is a C2 because when you rotate 180 degree, how do I said to you how to write the products 180 degree? This should be up. Just imagine all this up, all this down. Same geometry. Therefore, it has C2 axis. And you have a y-axis as C2 axis, z-axis as C2 axis, one more C2 axis like this. Now, what is another C2 axis? Yes, you have a C2 axis like this. you rotate like this. Am I correct? Therefore, this CL 180 degree, this CL come here, this CL come here. Again, another C2 axis like that. Therefore, how many C2 axis? 1, 2, 3, 4. Okay? One C2 axis, second C2 axis, third C2 axis, and fourth C2. 4 C2s. 4 C2. And all the C2s are perpendicular because this is our C4. All are perpendicular. All are perpendicular. Okay? Yes. Now, your octahedral geometry. What is octahedral? This is your octahedral. F, 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 F. What is this? This is just like this. Here sulfur, F, F. These two F towards you. These two F away from you. Okay? 4F, 5th F, 6th F. Now you have an axis from here to here. You have an axis, C4 axis. Because when I rotate, we'll get this identical geometry. It has a C4 axis. C4 axis. Now it has 4 C2 axis. Students, imagine F, F, F. 1 C2, I have a 1 C2 here. I just rotate. Okay? Another C2 like this. Fine? Yes. Now you have a third C2 like this. 4. One is this. This is C4. One is this. Second C2 this. Third C2 this. Am I correct? Fourth C2 this. Once again, your C4 is like this. Fine? One C2 like this. Second C2 like this. Third C2 like this. Fourth C2 like this. Therefore, it has 4 C2. 4 C2. Not only that, 4 C2 are perpendicular to C4. Therefore, you have a molecule like that, Cn and C2s, and which are perpendicular to each other. And another one is it has Cl, no C2. Okay, this is all about our axis of symmetry. This is all about the axis of symmetry. I think this videos will help you to get more examples. See benzene ring for address point of view, I will tell you. H. Another example. You know, it has a C6 axis like this. C6 axis. And it has a C2, 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 C2. Therefore, 6 C2 which is perpendicular to C6. Okay? Yes. Normally, this is my trick. I give you a simple trick. The trick is molecule having pyramidal bend, seesaw, etc. have Cn, no C2. Molecule have a trigonal planar, or square planar, or octahedral, or benzene-like, have a Cn and C2. Both are perpendicular. How is the trick? Very simple. Okay, thank you for watching. If you have any doubts, come in the comment box, we can discuss there.